Okay. Good evening, guys. Okay. So
Okay.
today's we are going to discuss about exponential and logarithmic functions. Okay. So from your previous knowledge, you know that exponential and logarithmic functions are inverses of one another. Okay. So if you have any function, let's say y equals to a to the b, you want to if you want to really insist, you just go log a y equals to b. Okay. So these are basically mirrored. Okay. Even if you have a graph here, okay, a log graph will look something like this, while an exponential graph will look something like this. Okay. And they are both mirrored by the plane of y percents. Okay. So this is from your previous knowledge. This chapter isn't really a hard chapter per se, but it is a tricky chapter because knowing the log functions is really important going forward. Okay, right. Let's go through some of the ones that you might have forgotten.
Okay.
Okay, so most important ones are these. Okay, log a equals 1 equals 0. Okay, anything power 0 always equals 1. That's the meaning behind this. So if I say 0 to the power of 0 is 1. Okay. 10 to the power of 0 equals to 1. X basically anything to the power of 0 will equal to 1. Okay. Log a to the a also. Oh, one moment, please. Okay. Coming again. Okay. So, okay, a equals a, log a, x. You can just take out the x. Okay. Okay, these are all things you have might have already encountered for in Form 4 and Form 5, so they're just going to apply them back again. But usually for Form 6, you're going to meet ln. Okay, so what is ln? Ln is basically when you have a logarithmic function in the base of the e, the natural number. Okay, so that is ln. That's how we usually write ln. Okay, so we usually write ln. The same thing, but we usually just call this the instead of writing the full thing as log to the base of e, you just write lm. Okay, it's shorter and it's accepted. Okay, so no worries there. Okay, time to make my brush short, smaller. Okay, all right. So let's go through some of these questions. Okay, so for the first part, okay, solve e to the power 0.016 equals to 2,200, 2,200. So how do we go about this? Okay, quite simple. You just go A. So let's go first question A. I just copy back. Okay, this. Okay, so just now, like I mentioned, you can just remove this E here by adding the natural log. Okay, so 0.016 equals to ln 2200. And you know that any exponent, any power that you have to a base here, you can just take it out. So that'll give you 0.016 ln e equals to ln 2200. And like I mentioned just now, ln is just the log of the natural number here, e. So when you have base e, that's basically 1. Okay, ln e is basically 1. Okay, so if that's 1, so what can we do? We can just take that out. So you start with 0.060 equals to ln 2 to 0, okay, and t, your final answer will be ln 2 to 0, over 0.06. Okay, so what will be the final answer here? I think it should be around 128.27. Okay, so this is to 5 as a 5 significant figures. Okay, this answer is equal to 5 significant figures. Okay. Okay, now let's try question B. Okay. Question B here, same thing, as you can notice, x is the power to the natural number e. Okay, so we're gonna do the same thing for this. Okay, I'll just take this out. So okay, ex plus e negative x. Okay, make sure you notice this. Minus 4 equals to 0. So how do we go about solving this? Okay, there is one method. Maybe you can try this. You let u equals to ex. Okay, so by letting u equals to ex, this becomes efficiently ex plus 1 over ex minus 4 equals to 0. So let's try to get rid of this. So how can we get rid of this? We can multiply the whole thing by ex. Okay, so when we multiply the whole thing by ex, we get e to x plus 1 minus 4 e to 0. Okay, just now we said that we're going to let u equals to ex, right? So that's going to give us a u squared minus 4u and plus 1 equals to 0. Okay, then you can use the quadratic equation. You will get something like u equals to 2 plus minus 3. Yeah, so since we know that u is actually ex, let's say ex equals to 2 plus minus 3, and then you introduce ln again. Okay, you can introduce ln again. So if you introduce ln, you get x equals to ln 2 plus minus 3.
Hello. Uh,
Yes, yes, you have to show the factorization, but due to some time, our time constraint, I'm just skipping that part. But you can just
okay.
show the formula
So
and just
u
put it.
minus 2 plus square root 3. Another
Plus
one
minus.
u minus 2 minus square root 3.
Yeah.
Right.
So you have two answers. So you can have two answers, and the final answer, if you input this in a calculator, you will get, if I'm not mistaken, 1.317, or you get negative 1.317. You have two answers. This is up to 4 significant figures. Okay. Okay, let's try question. Okay, would you like to try question number C? Maybe you can take around 3 minutes to try this question. Okay, for question C. So this is how you start question C. I'm gonna write it here because I have no space. Okay, for e1 plus 3x minus 9e5 2x equals to 0. Okay. Usually the most obvious way is, I would say, the fastest way. Okay. What would be the most obvious way? You see, is there's a negative here and there's a 0 here. You want to push it to the other side. So That's the right way, I would say. Okay. There's no one right way in maths, but this I would say the fastest way you can solve these kind of questions. Works. Okay. Then you might want to move these out. Okay, you can take the factors out. So I would go with something like moving this expression here and this expression there. So that'll be e1 plus 3x over e5 minus 2x equals to 9 over 2. Okay. So since these are the same base number, you can actually just say this is a minus. Okay, we just move them all into the power. Oh, sorry, not 9 over 2 is 9 over 4, right? Yep. So we can just say e1 plus 3x, okay, bracket that, minus 5 over 2x, bracket that, equals to 9 over 4. So you'll be left with theta, 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 negative 4, and plus this plus that, you get plus 5x. Okay. Maybe 4 plus 5x equals to 9 over 4. Okay. So I think from here it comes much easier to answer. You just make it into a ln again. So that'll be ln e 5x minus 4 equals to ln of 9 over 4. Again, this is the power of e to the power of 5x minus e, so you can just take that out, and ln e is just equals to 1. So 5x minus 4 equals to ln 9 over 4. And you can just actually put this first. So just put x equals to ln 9 over 4 plus 4 over 5. Okay, you can input this in your calculator. I think you'll get, if I'm not mistaken, 0.962.
622.
622, okay. How many values do they give? Okay. Here it doesn't really matter about significant numbers, so you can give a 622 or 62, as long as it's accurate enough. It's okay. For significant figures. Okay, so this is how you usually deal when there's a unknown variable in as power to e. Okay, it doesn't have to be e. You can always swap out any base. So let's say it's a 2 to the power of 4x. You can just use the log of 2. It's the same thing. Okay, it's the same process. Okay, you can just use the log of 2 on both sides. The same process. So now, okay, this is a typo. So it's not charge each logarithmic function form. It's a change each logarithmic form to equivalent exponential form. Okay, I think this is quite an easy one. Maybe you can have a try. I think this whole thing takes about 2 minutes. Have a try.
Okay.
Okay, so the final answers are 16, 306 power 1 over 2, and also 1 over 9. Okay, that's perfect. Okay, let's go to here. Solve the simultaneous equations. Yep. You will also encounter simultaneous equations of log. Okay. So how do you approach this type of question? Okay, maybe I can try this one out for you. Okay. So how do you start? Okay, so this is equation 1. This is equation 2. Okay. So you can start by since it's addition, you can actually put the logs together. So you get a I'll write it in short form. I'll just really write LG4. Okay. Actually put this as XY equals 2. Okay. This is one thing you can do. And then since you know this is 4, you can just move it to the other side. So you can get a XY equals to 4 to the power of 2. And 4 to the power of 2 equals to 16. Okay, there is one thing you can do. So that's your, you can say your third equation. Okay, so what's the next thing you can do? The next thing you can do is since it's minus, you can also do that. So that's log 8. So that will be minus you divide, okay, x over y equals to negative 1 over 3. Okay, then we can just move it to the other side. So x over y just equals to 8 power 1 over 3. And 8 power 1 over 3, how much is that? I believe that is x over y equals to 2 negative 1. So that is 1 over 2.
2.
Okay, x over y equals to 1 over 2. So
Hmm.
from here, you have four equations. I would use equation 2 and equation 3 and equation 4. Okay, maybe you can change how this equation looks like. Maybe you can change x equals to 1 over 2y. Okay, this is possible. Okay, so you can just change this form and then you can sum this up. So that'll be 4 into 3. Okay, equation 4 into 3. So that will be 1 over 2y times by y equals to 16. So that is y squared equals to 32. Okay, y squared equals to, yeah, correct? Yeah, y squared equals to 32. So y equals to either plus, you don't know how it is plus or minus, so plus minus square root of 32. How much is the square root of 32? I think it should be 2 set 2. Yeah, 4 set 2, yeah, right. So y,
5.6.
okay, for this type of question, try to keep everything either in set form,
Third. Okay, okay.
set form. Because when
4
you want
square
it,
root 2.
uh, oh yeah, first, because you might need to move these values a lot, and when you put it as a decimal, you might lose accuracy on the answers. Okay, so y equals to plus minus 4 set 2, and we know that x equals to 1 over 2y. So you can just put 1 over 2 plus minus 4 set 2. Then you'll get x equals to 2 plus minus 2 set. Okay. And you're done. So this is how you typically solve whenever the same things equation. I know sometimes some people like to do this.
Uh,
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 yes, yes.
can you scroll down?
Oh, sure. Oh, sure.
Okay.
Okay.
X equals to 1 over 2y. I use y equals to 2x. But
You
when I
sure?
substitute, I didn't get that answer.
You didn't get the answer. Okay, so you use the y equals
Yeah.
to x.
I substitute in the xy equals to 16. Is
Okay,
it correct?
x equals to 16. Okay, so if you put y equals to 2, that's a 2x squared equals to 16. So that's x squared equals to 8. I think you should get the same answer. The square root of 8 is also plus minus 2 set 2. Yeah, the square root of 8 is 2 set 2 also.
Oh, okay, okay. Because I was looking at 4 square root 2. Sorry.
Okay, that's why x is 2 set 2. Okay. There's another method. Another method would be making all of them the same base, meaning that you change all of this base 4, so you change this also as base 4, and then you can just substitute. Okay, you can just put whatever value equals here into this equation as well. Okay, meaning that okay, you square root this, so become like I mean, sorry, you have to cube root, and then square. Then you cube root and then square. You cube root and then square. So that's a lot of work, in my opinion. and it's not really worth it, especially during max T. You have very limited time, so this is the shortest method. I think you
Mhm.
can answer this question. Okay, let's go to question number 4.
So for x and y, both have two values, right?
Yeah, both also have two values.
Okay.
Oh, no, sorry. You get positive and negative. But the thing is, negative 4 over 2 does not exist. And negative 2 set 2 also does not exist. For final answer, just put x and y equals to 2 set 2 and 4 set
So
2.
positive.
Yeah. Okay, why is
Okay.
that? Okay, that's because log can only exist in positive values. Well,
Okay.
log doesn't exist
Because
in
if we
negative.
use negative, then we will get I.
Yep. I don't think even log lets you put negative values. Yeah, you just get math error because you
Okay.
cannot have like okay logic. Let's say
Mm.
4 to the power of a equals to a negative number. So can you put any number here, you won't get a negative number here. You will
Mm.
either get like a fraction, or get like a very big number.
So,
It doesn't make sense, right? It doesn't make sense for a log to be
mm,
negative.
yes. Later, when I write my answer, I write x equals to plus minus 2 square root 2. And then must I write
Yes,
rejected?
you can just put dot um, only when x equals to x and y equals to 2 set 2 y set 2, and then say um, log only accepts positive, only positive, something like this. You can just put that aside, then you're accepted. As long as your final answer is only the positive when it comes to log, then you'll be fine.
Mm.
Okay, let's
Okay.
go to the next question. Okay, for x log x equals to x to the power 3 over 100. Okay, this is the same question as question 2. Okay, try to do this question. Maybe this will take around 3 minutes.
Okay.
Okay, have a try. Okay, so this is how I would approach this question. Okay, so x log x equals to x3 over 100. Okay, but typically when just they mention log, that means it's base 10. The base is 10. If they don't refer to any other base, it's really base 10. So this is how I would solve this question. I would add another log into it. So I'll log the whole thing. So that's LG, okay, log x log x equals to log x3 x power 3 over 100. Okay, this is how I go for it. Okay, then through this, take this out. So there'll be log log x equals to log x3, and then minus log 100. Okay. So this is how I would try it, and this will give me log. Okay, let's remember this log is just squaring the whole thing. So it's in log x, then it's squared. Here, this 3, this cube, is referring to the x, not the whole function. So here we can just say it's log x, 3 log x, minus, okay, this is 10, right? 10 to the power, okay, 100. That is basically 2. Okay, that's basically 2. Okay. For simplification purposes, I am going to say log x equals to u. Okay, so that's be u squared minus 3u plus 2 equals to 0. Okay. So theta, 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 you'll get two answers. U equals to 1 or u equals to 2. So you get these two answers. Okay, so what do you do with this? You can just input back again. So log x equals to 1. So that is just basically 10. Okay, and also log x equals to 2, which will give you x equals to 10 to the power of 2, which is basically 100. So you will get two possible answers. Okay,
I
let's
don't
see.
understand the third line.
So like 1, 2, 3 here.
Yes.
Okay, so what I did here was I logged back the whole thing. I made it into a log function. So if I open it back up, okay, this is a x to the power of log x equals to x power 3 over 100. So I log the whole thing again. So both sides you add log, so that'll be log, okay, x to the power
Mhm.
of log x, okay, and
Mm.
also log x cubed over 100. Okay. So when you do this, you just remember you can actually pick up any power, okay, any power it has, okay, inside a log. So you can just take this out, it comes out, okay, log x, and you multiply by log x. Okay, why you cannot write this as 2 log? Okay, why you cannot simplify this 2 log x? Okay, this log times log, you're multiplying the whole function. You're multiplying the whole function. This is not the same as log x to the power of 3. X to the power of 3, this 3 refers to the x. Here, this square, you're actually referring to the whole function of log itself. Okay, so that's why this becomes log squared. Okay, okay, log x squared, okay, equals to log x, okay, 3. Here you can do 3 because this 3 goes back to the power of x, okay, and then minus by log 100. Okay, so you get two answers. Okay, how do you test these answers? Okay, you just put that value back inside the equation. Okay, so you can try it out. Okay, let's say it's x log x equals to 10 to the power of 3, okay, 100. Okay, let's try it left hand side and right hand side. Okay, so left hand side, okay, x to the power of log x. Okay, so let's say we take x equals to 100, so that will be 100. Okay, then log 100. Log 100 is basically 10. Okay, you get log 110. Now let's try right hand side. Okay, so 100, so that's 100 to the power of 3 over 100. Oh wait, this should be 2. Sorry. Yeah, log 100, right? So it'll be 2. Okay, so this also will give me log 2. So right hand side equals to left hand side. Answer is possible. You can try it with 10 also. You'll get the same answer. But you can, I don't know. Yeah, you can try it with yeah, you can with other answers will not give you this. You can try 200, 300. Yeah, that it won't equal the same. Okay, so these two are the possible answers.
X is 100.
Yeah, x is 100. So x can be 100 or x can be 2. Both accepted.
In my Jalan Kerja, which one wrong?
Okay,
From
let's see
start.
your jalan kerja. Okay, say x log. Okay, then you say 100. X log x equals 3. Then you say the a. Did you mention what is a? Ax equals to n. So
Mm.
log 100. Okay, base 100 equals to base 10 of x. Hmm, let's see. Okay,
Mm.
let's try to open. Okay, base 100. So 16.
Oh, the A is 100x.
Let me go
X
to
is log x.
okay, 2. x to log x to x equals to 3. Take out, you get 2 equals to this part
Mm.
here. Here it's log x to log divide by 3. So that will then it will give you something like you'll get 3 log x. Sorry, minus 3 log x over log x. You will not get this way. You will not get this. You make 2 mistakes, but 2 mistakes cancelled out somewhere, and you ended up with the right answer somehow. Wow. Okay.
The answer is wrong.
That is the right answer, but Jala kira dah salah lah. Okay.
No, my answer is 10.
Yeah, I told you what x is also 10. There's 2 possible answers. X can be 10, x can be 100. Were you
Mm.
listening just now? When you do it through this method, you get 2 possible answers, both also work.
Yes. Mm.
So that's why I said your final answer is correct, but then your working messed up.
Mm.
Okay, that's fine. All right, let's try the next question. Okay,
Okay.
this is log 2. I think you can see the pattern here. So since it's log 2 and log 2, you can just divide these up. So I'll give you log 2 x plus 5 over x minus equals to 3. Okay, then what can you do from here? You can just take out the log. So that'll be x plus 5 over x minus 2 equals to 2 over 3. Then that will give you 8. So that will give you x plus 5 equals to 8 x minus 2. So x plus 5 equals to 8 minus 2. That will be 8x minus 16. We go here further. So this will be 21. And this will be 7. So x will be 3. That looks like a
Yes.
complicated question, but then it's very straightforward.
Mm.
Okay. Okay. Let's see if we can okay, this one also. Okay, this one looks like a hard question also, but actually it's also an easy question. Okay, let's go through it like quickly. Okay, so
Okay.
find x to 3 significant figures. Okay, so this is just 10 to the power of negative 3.864. So you can just directly put this in your calculator. I think you'll get a 1.37 10 to the power of negative 4. And B, you also get this is log, so remember E, yeah? E, so E
Okay.
4.315 equals to 74.8. Okay, they gave you
Point 15.
if they say 3
Mm?
significant figures, give 3 significant figures.
Okay.
All right. Okay. Next question. Okay. So this one, okay, you have to substitute the answers at the final part. Okay, meaning that if they want you to see that this log a over 2, they want to see this log a over 2. So you have to make sure you get this bentuk. So I can try. I can give you a hint with the first question. Okay. So it says log a y over 3, 1 over 9, which is equal to the same as
T
log
to the power
a 1
-2.
minus log 3, log a 3. Then I can say log a1 is just 0. Then take out the 3,
Mm.
log a 3. Then just multiply them. Minus 3, you can put the value here is 0.477. You'll get the final answer. Oh yeah, the final answer cannot be an equal sign. It has to be the squiggly one because they also mentioned that approximately. So you have also put 0.954. I think this will be the answer. So this is how you answer this type of questions. Maybe you can try.
Can I do log a 3 to the power of -2?
Log a 3 to the power of -2.
Mm-hmm.
3 to the power of -2. Okay, how about you show me your working? How did you get this?
Can,
Uh,
can.
okay, try to see what's that. Or try all the questions. Okay, then we'll discuss. Okay,
Okay.
maybe 4 minutes each question on it. Okay, let's go for B. Okay, B. 3 or 4, maybe for two, minus, okay, 2. What's your final answer here?
-1/8.
-1/8.
1/8.
Oh, 1/8.
If in decimal, -0.125. 125.
Yeah, yeah. Okay. Yep. Okay, this is good. Okay, C. Final answer. I think 1.503. Yeah, 503.
505.
505. Oh yeah,
Mm-hmm.
okay, yeah, 505. Okay. D 0.301. Oh, yep. Okay, you get final answer. I think 0.631. Yep.
Mm.
Okay, that's good. Okay. Now for your favorite questions. Here's the graph of the following and state its domain and range. Okay.
Hmm.
Have a try.
Absolute favorite.
Hmm. Have a try. Take around. Okay, I think all of this will take around 6 minutes. 2 minutes for each sketch. This sketch, no need to be so precise. So let's try question A. So how does it start? F(x) equals to e2x minus 1. Okay. So E graph, just the natural number graph, will always look something like this. It will always look something like oh, number, something like this. Always go up
Hello.
like this. Ah, yes, can you hear me? Oh, sorry. I muted myself. Okay. So E graph will always look something like this. Okay, it will always go up and so on. Here's y axis, just y equals to 5 ex. Okay, at this point where x equals to 0, it will be 1 now. It will be 1. Okay, so from here, what can
Why
we
one?
y1 when
Mm-hmm.
x equals to 0, e equals to 0, anything power 0 is 1.
So
Okay,
e to the power of -1, right?
yeah, e to the power of -1, then that is 1. Oh, you said
0
e.
point something. Wait.
You mean e to the power of -1?
Mm-hmm.
8. E to the power of -1 is just 1 over e.
No need to type in the calculator and get the answer.
Oh, okay. For this part, I would say sketching, you can just leave it like this. Unless they specifically ask for you to give in significant figures, just
Mm-hmm.
you can leave it in like this form, okay, in a fractional form, or the simplest form you can find.
So not
But
one like 1 over e.
not one, not one. Yeah, like one over e. I think one over e is if it's e negative one, you can leave it as one over e.
Mm,
Okay,
okay.
so this is the simplest natural number form. Okay, so how about this question? 2x minus 1. Okay,
So you
so
won't change the 1 to 1 over e.
wait, I'm having a problem for y equals to any function. Okay, natural number function graph. Okay, how will it look like? Okay, there's two components here. Okay, so the coefficient beside x and also the number attached to the back. Okay, so how will both of these effect, I would say. Okay, how these both effect, I would. Okay, so this number in the front, okay, what does it do? Okay, it does a very simple thing. It changes the gradient of the graph. Okay, so what I mean by the gradient of the graph, okay, so let's say this number is something like this. Okay, let's say the number is like this. Okay. Let's say it's
Mm,
2x. Okay, e
okay.
to the power of 2x, okay, e to the power of 2x, and let's say e to the power of x. Okay, how about I use a different color? Maybe I can use a purple. E to the power of x. So if e to the power of x looks like this, okay. So e to the power of 2x will look even higher. You just go higher, okay? Go higher, okay.
Mm,
The gradient will be higher. So what does this back part do? Okay, this back part here, okay, minus, okay, let's say a, okay, minus a, or minus plus a. Okay, this changes how high and how low it can go. Okay, for if it's minus one, usually we lower it. Okay, if it's a plus one, we increase it. Okay, so it will be something more like this. So okay, let's say for this question, e for 2x minus 1, it will look
mm,
something like like this. Like this. Okay. Okay. So because it's 2x, it will go really steep, and then you have here 1 over e. That that's all you need to mention when it comes to graph. When it's sketching, you only need to mention the any point it touches. If it doesn't touch anything, you don't have to mention anything. Okay. You can also, if you want, uh, you
mhm,
can actually mention something like this. Okay, let's say when x equals to 1 over 2, you can actually mention this like you want. Okay, if you mention 1 over 2, you can apply this here. 1
mm,
if you want to, but even if you don't, it's fine. Okay.
okay.
So that's why I would say for e and log functions, when you want to sketch them, they're actually the easiest questions to sketch because it's just a straight. Usually, it's just one curve line, just one line here, and then everything else just comes into place. Okay. Okay. So I'll just maybe delete this part and delete and also delete this. So okay. So and then I'll just move this.
Mm,
To wait. Okay, this is A, right? I want to send this. Yeah, there you go. Okay, just want to put it as A. Okay. Okay, now let's I'll just go quickly through B and C. Okay. So for B and C, you can notice that it's 5 minus 5 EX. Okay, 5 minus 5x. Okay. So what is the
Mm-hmm.
points you have to remember? You have to remember when x equals to 0. When x equals to 0, you'll get 5 minus 5E0, which is 1. You'll get
0.
0. Okay.
Okay.
Okay, so then it will look like something like this. Okay, so this is negative. Okay, so how does this negative affect the graph? Okay, so if it's negative, it will just go down. Okay, just now we had a graph like this.
So the number before the E,
Also
only
same. If
only
x,
that number we must see.
no, you have to see this 5 also. The 5 will become, most cases, it, okay, let's say this is a 2. Okay, let's say this is a 2.
Mm.
Let's say this is a 2, this is 3. So when x equals to 0, this will become 1. So it will become 5 minus 2, which is 3. Then
3.
your y-intercept will be 3. So you have to notice that also. Just have to keep those things in mind. Okay. For now, it is not 3, it is also 5. So it's minus 5, so it's 0. So you know that when x equals to 0, y will also equal to 0. So it has a point here. Okay. So, oh yeah, I want to mention this now. Okay. So if it's a positive, if let's say A, E, T, A, X, 2AX. Okay. So if A is positive, the graph will go like this. If A is negative, A is a negative number, it will go down like this. If X is negative, it will go down like this. Okay. Yeah, it will go down like this. And if A and X are both negative, it will go down like this. So that's how the graph will look like. This is just a simple idea. I can always have an idea on how the graph will look like. So since here this is a negative value, okay, negative 5x, this will go down. So how does it go down? It will go down like this. Okay, just make sure you connect through the right. Okay, so you don't have to label any other point, but you can label just now like the same like and x equals 0 because it's already 0. This equation. Okay. Is there any other points you have to label? No, you don't have to label any other point. Okay. You can do something. Let's say you can take the asymptote. If you want to find the asymptote. Okay. So that means when x approaches negative infinity. Okay. When x approaches negative infinity, what will happen? Like one. So it become like 1/a, right? Okay. So it become like 1/e, right? X. So when x approaches infinity, then this will closely approximate 0. This part will start to approximate 0. So 5 minus 5 e to the power of 0 will slowly give you 0. So if this part turns 0 and negative infinity, I mean negative infinity, so you have a asymptote of 5. So you can actually mention the asymptote here is 5. Okay, if you that's something you can mention when you're sketching. Okay, now let's just go to C. Okay, we go to C and then let's take maybe a break.
Can you show again how you get the 5?
Oh, how do I get the 5? Okay, so this E is a continuous function, right? Natural number is a continuous function. It doesn't just break. Okay,
Mm.
it doesn't just break. So when let's say okay, x is approaching a negative infinity. So when it approaches negative infinity, E will equal to negative. Okay, let's say a very big number like 1 million. Okay, so this will approximately be like 1/, e to the power 1,000. Very small number, right? Almost 0.
Mm-hmm.
So now you just imagine like bigger number, bigger number, bigger number, bigger number. This will slowly become closely to zero. So when as this becomes closely to zero as it approaches negative infinity here, like somewhere here like, in the graph, okay, somewhere here in the graph, that means it will become 5 minus 5 some as this thing approaches zero. So 5 minus 5 times 0 is just equal to 5. So the asymptote here will be 5.
5. The
Now,
left one,
no asymptote here. There is no asymptote here. It will keep increasing until infinity. This will
but we
go on
label
forever. No need. There will be no label. Just this part. That's the whole one vertical
to
asymptote.
the graph on the left.
Graph
A.
on the left. Oh, A. Then this one is zero. This one never touch zero.
Mm. The
Okay.
one.
Okay. Let's say. Okay. Let's see. Yeah. Can say three two x. Okay. Let's say x is a very small number. A very small number, 1000. Okay, I ask you again, maybe 1000. So E, so that become like what, 2000 minus 1. What is 2000 minus 1? It also still be 0. Betul tak? This also approximate 0.
0.
Right? So the asymptote here is 0. I didn't mention just now the asymptote because it's already here. But if you want to mention, I no need to mention also. You don't have to do the line. You don't have to do this line because this already exists, right? No, so I don't mention.
The one.
So 1. I I think I just mentioned just now 2x minus 1. Okay, let's say if it's a negative number. It's a very big negative number. So negative infinity minus 1 is still negative infinity 1. So e will just either e to x minus 1 will just approach 0. Okay? Did I misunderstand something you're
Mm.
asking me?
Yeah.
Okay. All right. See you in 10 minutes and we'll continue class with question 9. Question 9 also you can see it's a sketching question. Okay, so just now we are dealing a lot with exponential graph, the E graph. Okay, now let's try log graph. Okay, so like I mentioned earlier, actually, where is it? Yeah, exponential and log. I mean, exponential and logarithmic graphs are just mirrors of each other. So if exponential graph goes through like this, a log graph usually goes like this. Okay. Logarithmic graph usually goes through in this way. Okay. Log graphs
Okay.
look similar to a graph, graph,
Mm.
but the main difference is cert only exists from positive integers. Okay, positive values. So a cert might start here and then continue. However, when it comes to log on any logarithmic graph, it goes all the way downward. Okay, if I have just now we are dealing about vertical asymptotes. Well, you will have horizontal asymptotes. Okay, when it comes to long
Mm.
graphs. Okay, all right. So let's try this one. It's quite easy. Okay, 2 log x. Okay, have a try. Maybe just a minute or plus. It should be good. Okay, so this is the
No.
no, it is not actually correct.
Okay.
Okay, why I say it's not correct. Okay, okay, let us draw normal lawn. Huh? How does
Mm.
normal lawn look like? Okay, so normal lawn will look something like this. Okay, lawn, will look something like this. Okay, so if you were to have a modulus here, I can you? I don't think you can. Wait, let's have a modulus that. How would that look like? I think it will look something more like this lah. Um, since that x is the modulus, not the not
Mhm.
the not the whole function, just the x. So actually, you can input negative values here. It is a logarithmic graph, but since x is modulated, so you can actually have two graphs here. You have one going here, and another one going here. But both are mirrored. You have two. The value in front of the norm will just change this curve. That's all.
But even if we draw like this, still the x will have negative value, right?
Yeah. No, y will have a negative value. X is all positive one. X, okay, I put here negative 10. Okay, x equals to negative 10. Okay. X will then become what? X equals to 10 because it's modulus. Yeah, become modulus. So logarithmic graph doesn't exist at negative values, but it can exist in positive ones. So even though the negative is negative here, it can still exist. So it become like this. You have two sides. One here,
Oh.
one for all negative values of x, all for positive values of x. Okay, and they'll be mirrored on the y plane. Okay, so can you guess what is this value? Or don't you guess? I just tell me what is this value? This value
One
is 1. Yeah, this one will be negative
negative.
1. Yeah. Okay. Usually you don't have this. You won't have this calculated. Like I mentioned, a long graph it has asymptote. Long graph will always is the same for exponential graph and also logarithmic graph. They will have asymptotes. If an exponential graph has a vertical asymptote like this, okay, you have
Mhm.
this asymptote. You just imagine mirroring this one. So it will go like this, right? You have here. So this will be its asymptote. Okay, you always have an asymptote. Okay.
Mm.
Okay, let's try this one. Okay, this one also sketching. Okay, you have to know how to sketch that. Okay. Okay, sketch the following functions on the same axis. So A, B, C, and D is all on the same axis. Maybe you can use a different colored pencil. Maybe red, blue. If you have other colors of pencils, you can try. Take
Okay.
around like 5 minutes. Okay, this question is a bit hard. Okay, so I will also give you like around 5 minutes plus. Okay, take 5 minutes plus. Try this question out. Plus. Okay, so we have how many here? We have 4. Okay. We have 2x minus 3. We have 2x plus 1 and negative 2x minus 2. I think you didn't manage to do negative 2x minus 2, this one. Okay. Okay, so this is roughly how the graph should look like. Okay, I'll use different colors. Okay. So for the first one, which is negative 2x, is it? Or just 2x, yeah. So just 2x. Okay, so it will be something like this. I use a yellow color. I'll just go like this. Okay, this will be just 2x. Okay, second one, 2x minus 3. Okay, so 2x minus 3 will look exactly like 2x. Chuma, it will just be down here. Lah. Okay, 1, 2, 3, it will just be down here. So why down here? Because when x equals to 0, it will be negative 3. So it's the same function, but just down lower. Everything will be minus 3 future. So it will just be like this. Okay, it will just be minus 3. Okay, here will be uh, x equals 2, which is 1, okay, will be 1. Okay, then your third function, 2x plus 1. Okay, so how will 2x plus 1 look like? Okay, it will have slightly higher, so okay, slightly higher. Okay, why slightly higher? Okay, so imagine when x equals to 0, then it will just be 2, 0 plus 1, 2 to the power of 0 plus 1. So when it's a 2 to the power of 0 plus 1, that is just 2. So here will be 2. Okay, final one, negative negative 2x minus 2. Okay, so just now the 2x plus 1. Okay, it'll look sorry, the 2x minus 3. So it goes like this, right? So this one will go down. Okay, it'll go down like this. Oh, I said I'll use all different colors. Huh? Yeah, no, okay. So there's a label here. So this will be, I already labeled as 2x. Okay, so this will be 2x minus 3. This will be 2x plus 1. Then finally you have this one. Or it should be lower. It should be lower like this. Okay. This one, what's the value? Okay. So it's negative 2x minus 2. So when x equals to 0, y equals to negative 2. So, I got all.
For all these graphs, must I find the asymptote?
No need. You won't, okay. This is just to help you during the question, but usually they won't ever ask a question like this all four together. Very rare. Like you go through the past year papers also. Almost impossible they ask you something like this. Okay.
Mm, because this is very easy.
No, no, they won't call it. Actually, it should be this should be negative negative two. Yeah, okay, that's why I was confused. Okay, it should be negative two, and yeah, both of them will intersect at this point. It's negative 2x minus 2. Okay, why they? Oh, wait, I do. What is wrong with me today? Okay, uh, like this. Okay, this will be this will be 3. Okay, so we need to. Okay. Okay, why they won't give you a question like this? Okay, this confirm. Yes, this is you can say this is easy, but this is a question that is not simple. Okay, if you notice any past year, if you started doing any past years, okay, this is just some knowledge on you. All STPM questions are simple questions, very direct. They will tell you what they want, but the method for you to find it is not easy. Okay, it's not easy. Whatever they want you to find is actually very straightforward. Okay, it's very easy but not simple. Okay, this one
Mm,
is what we call a simple question. You just have to sketch. Okay, sketching this is simple but not easy because each one takes a lot of time. STPM prefers easy questions but not simple questions. Okay, so maybe they will give you a question that is not very very easy. You just have to sketch. Okay, let's say like one only. You have to sketch only one function. Okay, fx. Right? It could be a composite function. So from x from 0 to 3 different function, from 3 to 7 a different function, and so on and so forth. That's how STPM is different compared to uh, other exams because they will tell you what they want. They will always tell you what they want. It's very direct. But the way you find it is not direct at all. You have to apply all the knowledge you have gained throughout your 6 months for the semester, and you have to apply all of it through one question. So that is why
mm,
STPM, some people will say it's hard because if you don't understand even one subtopic, like example, sequence and series, there's a binomial expansion in that. So if you don't understand that one small subtopic, then you might not actually understand how to expand the question at all. So that's the problem with a lot of people when they go through STPM. They think that you can just do the same thing they did in SPM. They don't have to study some topics because some topics are very easy, so they just like to just, I mean, some topics are very hard, lah. Okay, and you can choose, right? You can choose one of them. So some people don't like to study that at all. But for STPM, no, remember, for maths, you have six questions, compulsory answer, and one is to choose one, two choose one.
optional.
Yeah,
Mm,
optional. So this six, you have 6 chapters in one semester. You must understand all six to get the answer. If not, you cannot.
mm,
Okay. The two choose one was you need to understand almost all chapters to know this. So it is you cannot just skip a chapter. It is impossible for you to survive STPM by skipping chapters. Okay,
Mm.
okay. So that's just my opinion on it. Okay, how about we try something a bit hard? The sketching takes a lot of time. I don't have much time. Okay, so let's try maybe question 13 and question 14. Okay. These are big harder questions and questions that might come in the exam paper.
Mhm.
Okay, maybe you can try both of them together. Then we discuss this and maybe we can end the class here. Okay, have a try. Okay, let's go to the question. Okay, solve log 2x minus 1 equals to log 4x minus 3 minus log. Okay, so how will we approach this? Okay, so one way you can approach, yep, exactly, put everything together and then okay, for an equation you get two answers. You get 3 over 2 and 1. Very straightforward. Okay, very nice. Good job. Good job. Nothing missing, nothing, everything good. Okay, so mm. Is there any other way you can solve this? No, I don't think so. If you want to, even if you wanted to make your life harder, I don't think there is. It's a very straightforward question. Okay, let's go to this one. Okay. Check and try this one here already. Solve to ln z x minus ln 1 minus z x. So, okay, so how do we go about solving this? Maybe we can put this x here. So do ln x, right? So you can actually do this. So 2x minus ln 1 minus x also 2. Okay, why? Because this 2 is referring to the ln, so I can just move it inside. So set x and okay, no problem, halfway, no issues. Okay, so I'll just give you x again. Okay, and then because divide, so that's ln x over 1 minus x equals to 2. So I'll just give you x over 1 minus x equals to natural number, okay? Square, then you can move it to the other side. X equals to 1 minus x bracket square. So x equals to 1 re square minus x e square. Move it to the other side. So get x equals 1 plus e squared over so e squared. So x is equals to e squared over 1 plus e squared. You'll get something, I think the value should go around 0.881 if it's a 3 significant. Okay. Okay, you have sent your working. Let's see. Okay, yeah, you almost finished it. Yeah, halfway. Yeah, if you continue, you already gotten the answer. Okay, I just saw the workings now. Okay, okay, so 15. So this is a special question. I wanted to do this right before we ended class. Okay, so find x such that log px equals to and then without using calculator. Okay, without using a calculator. So when it says without using calculator, usually what that means is they want the value. The value is usually something that is very perfect. Okay, very perfect. It could be irrational. It could be irrational number, but the fraction will look really nice. Okay, either that or a whole number. Okay, so how do we start this? Okay, let me just copy the question first. Okay, log bx equals to 3 over 4 log b 16. plus 2 log b3 minus log 2. Okay, so since everything is the same base, okay, maybe you can do something about that. We can actually put this 3 over 4 here. We can actually move it inside, so that will become log b 3 over 4, so that's 16 to the power of 3 over 4. Okay. Plus, you can move
I
the
sent my working.
for question 14 or question 15.
15.
Oh, okay. I'll have a look after solving it also. Okay. So
Okay.
b log b 3 squared minus let's log b 12. Okay. So how much is 16 for 3 over 4? I think you'll get 8. So that'll be log b8 plus log b9 minus log 12, log b12. Okay, so then you just have 8 times 9, that is 72, if I'm not mistaken. Yeah, 72, so that'll be 72 over 12. So log
Mm.
b 72 over 12. I'll just copy this log bx, log bx, log bx. Okay, so 72 over 12, I think you'll get is log b. Okay, after 6. So x equals to 6. Okay, sometimes you don't even need to change it, you can just do it directly. Questions like these look intimidating, but are usually very straightforward.
Mm.
Uh, this one, 16, do we have time? Actually, or we have extra time? It's okay, lah. Maybe I can try. Okay, you can try. So just go through this quickly. Okay, given log 9 plus 9 equals to okay, where a is a value between 0 and 0.5. Okay, so 0 and 0.5. So definitely give me a negative value. Okay, so where do we start with this? Maybe we can try something.
Okay.
We try by simplifying the 2 over 2 over 3. Okay, we just write like this. Okay, so how can we write this down? We can also say this. Okay, we can say 2 over log 3a is the same as 2 over 1 over log a3. Okay, is inverse. Okay, the inverse property. Okay, which equals to basically 2 log a3. Okay, or you can also write this down as log a9. Okay, you can also write this down as log a9. So we just did that to make this log a9. Okay, why I want to do a9? Because everything is a. You see, everything is log a, log a, log a. Only this one. So that's why we needed to change this one first. Okay, so then we copy back the question. Log a x minus ba plus log ax equals to log a9 plus log a1 minus 2. Then what else can we do? We can actually make this into, okay, let me see that. Log A, x minus b a. Oh wait, I can add both. Okay, now I'm gonna use that first. Close to okay, log 9 a 9. Okay, go. Maybe you can go with this inside. Put it all as one thing. Okay, log a 9 minus 18. Okay,
Mm.
okay, then over x. Okay, so and from there can we solve it? X can we solve it like that?
You can also times at the left, right? The
Can
x.
also you can times it at the left. Oh, okay, can also, but I was trying to put it. Okay, la. Then I'll get a log a x square minus x.
B A x B A.
Okay.
Mm.
Okay. If I want to go, that should be an easier way. 16.
So now we can compare.
Hmm. Can be compared. Yep, we can compare also. So then we have two things. Then we can say x squared equals to 9. And then we can
Mm.
say x b equals to 18. So if x squared equals to 9, then we can say x equals to plus minus 3. And
Mm.
then since you know
But
it's
only take three, or we can take both.
if the final answer is still positive, we can take both. So we have to test it out. We have to put the value inside the equation again, see if it works or not.
Oh, okay, okay.
Okay. So it's the same like house, yeah. I remember I'll give a like an analogy. This you can actually use like the logic of area. Okay. Some area questions will say x plus 3 and then x minus 4. Okay.
Three, four.
Uh, so
Okay.
sometimes you can have this question where you can have like multiple answers. Maybe you get a 3 and 7. Okay. Okay. So in this sense, if the answer was x, you got two answers right. It's 3 and 7. So obviously 3 cannot because 3 minus 4 you get -1. Impossible. So you have to take 7 here. Sometimes your answers could be maybe 5 and also 8. Depending on we don't know the question, right? So we don't know the question, we don't know the value they give. So it could be 5 and 8. So then since 5 and 8, then it can also be that both answers are accepted because 5 minus 4 is still 1.
Mm.
And 5 plus 3 is 8. So both can be accepted. So you have to check back the original equation. So it works or not. Okay, so you have two answers. X equals to positive negative 3 and b equals to positive negative 6. Okay, you don't have to take any part. Okay, you can just actually start it from here now. Okay, log x plus this one. Okay, let's see. Let's say we take the negative part. So that's log a uh, x squared minus x b a. Let's say the negative part. So that'll be 9 minus 9 minus negative value. So this is a negative 3 and negative 6. So that give you a positive value again, will give you 18. So 18a. Okay, so oh yeah, we don't know yet also because this a we don't know how much. This a we don't know how much. So actually you can give both answers. Just put positive
Three,
negative 3 and positive negative 6.
6. Okay.
All right. Okay, so okay, I think that concludes our class for today. Later send the recording and also this PDF for your group. Do you have any questions for today? Oh, wait, let me check your answer. You just send me an answer, right? 3, yeah, you also got the same answer. X equals 3 and D equals 6. Okay, good. Good, good. Okay. Do you have any questions?
No.
Okay, so actually managed to almost finish. Actually, you almost finished chapter 1.
Chapter
There's
1.
only one more, trigonometric function, and then we can go really fast in chapter
2.
2 and then catch up. Maybe I will schedule an extra class. Do you know when is your chutti? Your chutti
Chutti starting on 10.
starts on 10 and 2,
Starting 10 until next year.
2 January lah. 10 to 2.
Mm.
Okay, 10 to 2. Okay, I'll keep that in mind. Maybe we can have extra classes during that time. Okay. All right. Thank you for coming today. Thank you for attending the class. See you next week.